So, Assalamualaikum. We are from Group 8. So, we are going to present about our DFMA project, which is a hole puncher. So, first of all, this is our group members. We have Muhammad Imran bin Norazam, Amirul Muzzammil bin Norman, Muhammad Fahmi bin Muhammad Samuri, and also Muhammad Affif Iskandar bin Rafie. So first of all, for our introduction, so basically we make a project about a manual hole puncher. So what is a hole puncher? Which is a common office tool used to punch hole in a paper for fillings. So for the original design, the hole puncher itself have total 8 parts consists of base, handle holder, handle pin, base pin, cutter, spring, and also rubber cover. So the material used is steel and aluminum and rubber. The assembly time for the hole puncher is 32 seconds. So the reason why we chose it is it have a simple mechanical device. It also have a clear opportunity for improvement and also easy to deassemble and study.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran bin Norazam. My metric number is DN230025. And I would like to proceed to the next slide, which is the DFMA improvement. So for our project, the hole puncher, we integrated the handle holder into a base, we remove two parts, which is holder and base pin, to minimize the parts of the hole puncher. The second one is we change the function of the handle pin and we replace to the snap fit to align the small pin during the assembly of the hole puncher. For the third improvement is we spring sit between the snap fit trunnions, which is the same feature for multiple function. And so for the result, we has reduced the part from 8 parts of the hole puncher to 6, which is the percentage we reduced to 25 reduction. And the assembly time is cost before the improvement is 32.64 seconds, and after the improvement it will become 23.35 seconds, which is 29% faster than before the improvement. And the design efficiency from 46%, and after we do the improvement we get to the 65%.
The next one is safety integration. So how is our design safer? For users, we can say fewer small part equal to less chance of pin falling out, integrated snap fits, more stable handle movement. And next one is no loose fastener that can become projectiles under spring tension. So for the assembly workers, it's easier for handling, which is because of no tiny pins to drop or lose. The next one is no alignment struggles. Snap fit just pushing, as we know. Yeah. Next one is less repetitive stress from precise pin alignment. And the last one is reduced mistake equal to less rework and also equal to less frustration. So the FMA principle, we can say that fewer parts directly result in fewer opportunities for assembly errors.
Assalamualaikum. My name is Muhammad Fahmi, and I will be talking about the benefits for society for our product, the hole puncher. So, how does this help people and the planet? So, for the first part, for the user, the benefits, the product will be more reliable and it won't fall apart because with less material use, it is most unlikely for the product to have any failure. It's less chance also to happen any critical error with the product with less parts. Next, for the maintenance and the repair, it is also easier to take apart if needed because most of the parts have been integrated together, so there are less parts for it to take apart if needed. Next part is the environment. With less material use, it also results in less waste. So this is also good for the environment and also uh, cost effective for the company. Next, for recycling, with fewer mixed materials, it is also easy to recycle because the user often have to differentiate and separate different materials for recycling process. So with our improved product, uh, fewer mixed materials is also will become easier for the user. Next is the sustainability impact. We eliminated the handle holder and also the base pin. This results in less material consumption. It is also 29% faster assembly, meaning there is less energy use in the factory, and also fewer parts also results in less packaging and shipping. This is also cost effective for the company. So this is all for me. Thank you.
Assalamualaikum, my name is Amirul Muzzammil. Here I'm going to proceed for the next part of our presentation, which is responsible engineering reflection. So why should safety and society matters in DFMA? First, design decision affect people. So why design decision affect people? First, our choices impact worker who assemble the product and also impact users who trust the product. Everything that we decide on the product design will affect how our workers assemble the product on the production line, and also when the product is finished, user who use the product will get the benefit of our decision that we make. Second, efficiency and safety. So basically, making assembly faster should never make product weaker. So in DFMA, there is a part where we should make the assembly faster, but at the same time we must prioritize the product so that it doesn't affect the fragility or the durability of the product. So next, we must balance cost reduction with durability. In order to produce product that give high profit to the company, we should take into consideration the durability of the product, which is if the product is durable, our customer will satisfied with the product and make them to trust our product more in the future. So for the remark of our product, which is the snap fit, after we make a few discussion, we know that plastic snap fit must be carefully tested for long-term use because even though it can reduce the assembly time, it doesn't hold enough for long-term use. So maybe we can change it to another idea in the future. And next, for the we design for life cycle, not just assembly. So in this 2026, every company already moved to more green product because that is the regulation that our company or entire world have decided. So we must take into consideration of how will the product be repaired, how will it be recycled, and what happened at the end of life. So these three things we must consider during the design phase of the product. And lastly, as a designer or engineer of the product, we must ensure these three things, which is make it easier to build, make it safer to use, and lastly, make it kinder to the planet. So I think that's all the video presentation of our group. Thanks to Dr. Azli for the guidance and the knowledge throughout the learning process. That's all from us. Thank you.